Welcome! In this series of videos, we will look at topics common to both the PowerBasic Console and Windows compilers. Today, we will look at formatting or converting numeric variables to strings. In this series of videos, we'll be covering topics which are common to both the PowerBasic Windows compiler and the PowerBasic Console compiler. In order to do this, I've set up a small common library to allow us to display information on the screen from our program regardless of whether you're using the Windows or the Console compiler. There are three basic functions in this common display library. There's prep output, log, and wait. When you're outputting numeric variables to the screen or to a file, you may have to convert them into strings. Today we're going to look at a number of ways of actually doing this. First, we'll create some local variables. And we're going to create a simple for next loop to send stuff out to our log. Now we're going to initialize our start and end variables, as so. Now, if we attempted to output the value of long R to our log, it would error. The reason it's erroring is that the parameter we're passing, which is numeric, is not what the function is expecting to see. It's expecting to see a string. So we need to find a way of turning this numeric variable into a string. There are a number of functions to perform this. We'll try this one first. This is the string function. If we run that now, we'll see we quite successfully get the numbers 1 to 10 output on our log. That's fine, but to be clear what we're actually sending out to the log, what we'll do is we will add a character to the beginning and the end of this string just to see where the string starts and ends. And if we run that now, we'll see there is a space before the number all the way down. Now, what is this space? Well, if we change our start to be a negative number, and we run from -5 to 5, and we run our program now, you'll see that the space at the beginning is for the sign of the variable. It's not displaying it for the positive numbers, but it is displaying it for the minus numbers. Now that's fine, but what if we don't want to have the space? If we go back to 1 to 10, is there a way of actually removing this space? Well, what we can do, if we enclose this function in brackets and we put it as the input to a second function, the trim $, the value in here, which starts off as 1, will be turned into a string, and then any leading or trailing spaces will be trimmed off. So if we run this now, we'll see that the leading space has disappeared. Now, are there any other ways of actually doing this? Well, if we go back to our original, we can use the format command. The format command would do exactly what we did with the trim and the string command. However, the format command can do even more. If we're going between, say for example, 1000 and 1010, which would print out as you would expect, the format command allows you to put a mask in, so you can do slightly more. This is an optional parameter to the function. What we can do is set it up so that it will output commas, as in there will always be a 0. There could be optionally two numbers before the 0 then there'll be a comma, and if there's any numbers beyond 1000, the comma will appear in the output. So if we tried that now, we'll see that we have a numerically formatted number. If you decided that this was perhaps going to be a currency and you wanted to see the decimal point, you can change the function as so. This barely scratches the surface of what format can actually do. If we're, for example, outputting something from 990 to 1000, we'll see that it goes from 990 all the way to 1000, but the 1000 value takes up more space than the 900s. Now if we wanted all this to be right-hand justified, so that the column was nice and neat, there's another string command we can use to further format it. We'll enclose this in brackets, and we'll use the rset command, and the rset command takes a parameter which is the number of characters, spaces that you want the string to have. In this case we'll go for 6. Let's go for 8. And rset right justifies the value in here, this value here, into those 8 characters. So if we run that now, we'll see that the value is quite happily right justified. Now another command which will be quite useful if you're doing any formatting, if we comment these 3 lines out, and what we're going to do now is we'll set up a new variable we'll initialize it. It would be 0 anyway, but it never does any harm to initialize these, and we're going to do another for next loop, and in each iteration of this loop we're going to increment the counting variable, and then we're going to output to the log exactly the same as we did before, but this time instead of the format command we're going to use the using $ command. Now it takes a variable number of parameters. Say for example we want a piece of text on the screen or to the file. Now what this is going to do is each time it cycles round, long count will start off being 0, so the first time in long count will become 1, so it should say value of entry 1 because it's taking a long count and matching it into this mask, and it'll tell us what the value is, which is coming from long R. So we try running this now. It will tell you entry 1 is 990 and entry 11 is 1000. That can be very useful, as this will take a variable number of parameters. As you will see, it takes both string and numeric expressions, and can be quite useful for outputting information like IP addresses, as in down here. So you will find that this small number of numeric to string conversion functions will be very useful within your applications. That's it for today. Thank you for watching.